Okay, so number 5 and 7 are related rate problems. So we're going to draw a picture. A ladder leaning against the building. We'll make a right triangle. So if the bottom of the ladder slides away, that's my change in x over change in time as 2 feet per second. Then it tells us that the top of the ladder is 12 feet off the ground. So I can use Pythagorean theorem to figure out what x equals. I don't know what just happened there. So x equals 16. So now going back to my Pythagorean theorem, I'm going to find the derivative. But everything's with respect to time. So every variable needs the derivative with dt. So this is 2x dx dt plus 2y dy dt equals 0. So I'm going to substitute in everything I know. Now we have to simplify and solve for dy dt. So 2 times 16 times 2 is 64. We're going to subtract the 64 over and divide by 24. And then reduce, so we get negative 8/3, and that's feet per second. And now number 7. So we have our volume formula. So if I'm going to find the derivative with respect to time, 3 times 4/3 is 4. Okay, but now before we can do anything else, I need to get all of my units. I have a diameter of 18, but my rate here is in feet per minute. So I want to change my inches to feet. So to do that, 18 inches, changing that unit to feet. Well, it's 1 foot for every 12 inches. So 18 over 12, that is 3.5 or 1.5 feet. But that's the diameter. So the radius is half of 3.5. So 3 over 2 times a half, and that's 3/4. And my change in volume over change in time is 5 feet cubed per minute. We want to find the change in radius, so I'm going to plug in everything that I know. We're going to start simplifying. So then 4 times 9/16. This 4 can reduce the 16 to 4. So I have 9/4 pi dr dt. So then simplifying for dr dt, going to multiply both sides by 4/9 so that those cancel. So I have 20 over 9 equals pi dr dt. Then I have to divide by pi. So my final answer is 20 over 9 pi, which equals dr dt.